Right. Hi, guys. Thank you for joining us. Going to be presenting on trigonometry. This is lesson 5. I welcome you all to EduBlush Visual Academy. We are going to be looking at lesson 5, which is developing from lesson 4. Right. In lesson 5, I'm going to be looking at negative angles. Okay. Right. Hope you mastered the previous lesson. Right. Let's start with our. Let's look at now the let's look at the lesson from your trigonometry, which is negative angles. Okay, right. On your negative angles, right, we are going to be basically developing something that you got from the first lesson. The first basic lesson, I explained that we are looking at negative at angles, and I said angles, they stretch from negative infinity to positive infinity. Okay, our angles are from negative infinity to positive infinity. Any angle which is positive, it means it was measured in an anti-clockwise direction. And any angle which is negative, it means it was measured in a clockwise direction. So I'm going to look at a reduction formulae, but specifically focusing on those that are measured in a clockwise direction. In other words, negative angles. So I'm going to look at trigonometry. Right, trigonometry, but basically focusing on, I'm going to be focusing on, I'm going to be focusing on reduction, reduction, formulae, um, of negative, negative angles, negative angles. Okay, right. We're going to be looking at this negative angles. Right. A negative angle is basically an angle which is measured in a clockwise direction. Okay. A negative angle, we are saying a negative angle is an angle, which is measured in a clockwise direction. In a clockwise direction from the x-axis. Okay, right, from the x-axis, meaning to say if I've got something like this and I measure an angle in this direction, say 20 degrees, this becomes negative 20 degrees because the direction that I took is a clockwise direction. Then that angle is going to be negative 20 degrees. So once you see an angle like negative 40 degrees, it means it's in the fourth quadrant. Like this negative 20 is in the fourth quadrant. If I say negative 100 degrees, well, I'm now counting from there. This is 0. That would be negative 90. That would be negative 180. I'm going in a clockwise direction. That would be negative now 270. That would be now 360 in that order. So if someone says, which quadrant is negative 100? Negative 100, I know that from there to there is 50, from there to there, negative 100 is between negative 90 and negative 180. So negative 100 is basically in this quadrant, which is the third quadrant. That's where negative 100 is. Okay, right. If someone says negative 200 is in the second quadrant. Okay, negative 300 is in the first quadrant, something like that. Okay, so all I'm trying to illustrate is a negative angle is measured in a clockwise direction. So when you are positioning it, you are going in the clockwise direction. Clockwise simply means the direction that the clock takes. Okay, if you look at your watch, your clock, it turns in a certain direction. That direction is what we are calling the clockwise. Now, if you look at this cast diagram, starting from 0, it means you'll be going in this direction. And that is the direction that we are calling the clockwise direction. So clockwise direction, there you go, there you go, there you go, there you go. That's clockwise direction. Okay, right. That's very, very important. So at this stage, given an angle, you should be able to tell which quadrant it is when it's a negative angle. Now look at this. Let's look at this. I'm given something like sine negative at theta, and I'm supposed to reduce this. I'm just going to use the basic reduction formula that we know. Sine negative theta. It means if I'm on my cast diagram and I measure a theta degrees in a clockwise direction because it's negative, I'll end up in the fourth quadrant. That's where negative theta is. So sine negative theta is where? In the fourth quadrant. Right. Where am I measuring it from? From the x-axis. What is sine in the fourth quadrant? In the fourth quadrant, sine is negative. But this is deduced from the x-axis, so this will be negative sine theta, something like that. Now, what about cos negative theta? The same thing. This is in the fourth quadrant. What is cos in the fourth quadrant? Fourth is actually cos is actually positive in the fourth quadrant. So that would be positive cos theta. It remains cos this side because this is also coming from the x-axis. You can see that I'm starting from 0, measuring it. And 0 is on the x-axis. Okay, right. Now let's look at tan negative theta. Tan negative theta, the same thing. This is in the fourth quadrant. What is tan in the fourth quadrant? It's a minus, but this is measured from the x-axis, so it remains minus tan theta, something like that. Okay, right. Now that's very important. That is very important. That's how you reduce your negative angles. That is how you reduce your negative angles. Okay, right. Let's look at how you can also look at these things. Okay, now if I am to take you through an example. Now look at my example number 1. If I'm to look at number 1, simplify the following. The following. Okay, simplify the following and express your answers in terms of theta. In terms of theta, right? I'm going to say, okay, you are given something like sine, look at this, theta minus 180, something like that. Right. Look at my first example. Simplify that. I'm going to go through this example using 2 basic methods. Right. The first method, I'm going to say, okay, this is theta minus 180. Under normal circumstances, this was supposed to be 180 minus a theta. Then it goes back to functions that are deduced from the x-axis. But this question presents itself in the sense that it's now theta minus 180. Now, once you see such, it means this is a negative angle. Okay, right. Now, so how am I going to simplify this? I'm simply going to say sine theta minus 180. Okay, since it's a negative angle, I'm going to add a revolution to this so that I can address the negative angle. Okay, so I'm going to say this is going to be sine what? Theta minus 180 plus 360, something like that. Okay, this is going to be equal to sine what? Theta plus 180, which is the same as sine 180 plus a theta, something like that. Now this is going to be equal to, I'm now simplifying. I've rearranged this, and I've managed to clear off the negative or the abnormal setting which we had in the first step. Sine 180 plus a theta, this is in the third quadrant. What is sine in the third quadrant? In the third quadrant, sine is a negative. But where is the function coming from? 180 is on the x-axis. This we did in the previous class. So I'm going to say you are going to maintain, since it comes from the x-axis, remember, you keep the same trigonometric ratio. So this will be negative sine theta. You simplify that. Okay, that is the first method there. Let me take it using the second method. The second method there. Right. On my second example method, I'm just going to say this is sine. I'm going to twist algebra a little bit. Right. This is sine. This is sine theta minus 180. Since it's theta minus 180, I'm going to factorize a negative because I'm trying to make sure that it goes back to 180 minus a theta. Then I can identify the function. Okay. So I'm going to pull out a negative or factorize that. Negative 1 into that, you get a theta. Negative 1 into negative 180, it's plus 180, something like that, which is going to be equal to, this is now sine what? Okay, if I say negative into theta, I'll get negative theta. Negative into negative 180, I'll get positive 180. Okay, right. From there, this is now negative outside. Then inside is now 180 minus a theta. I'm just rearranging. Then that's a square bracket. Okay, right. But this is sine of a negative angle. This is a negative angle. Sine 180 is a negative angle. So it means I can call all this angle alpha. So it's as good as sine negative alpha. And sine negative alpha is the same as negative sine alpha, which is what? Negative sine alpha. But alpha is 180 minus theta. So it means it's negative sine what? 180 minus theta, something like that. Okay, if I'm to simplify it, it's going to be negative sine 180 plus a theta second quadrant. 180 minus theta is in the second quadrant. What is sine in the second? It's positive, so it's plus sine theta, which gives you also negative sine theta. Ooh, that is quite long, but if you take it using the first method, it will be very, very simple. I'm just trying to show you how you can twist and turn the same thing. Okay, but the first method there, I'm sure you can all agree that it's fairly faster than the second one. Okay, right. Let's look at this another example. Let's look at B. Simplify. I'm looking at something of this sort. This is cos what? This is cos a 1 theta. This is cos negative theta. Negative theta. Negative 180. Oh, now that's a negative angle. How do I simplify this? Once you identify that this is a negative angle, how do I know it's not it's a negative angle? Looking at the previous functions, our functions from the x-axis it's 180 plus or minus theta, um, uh, 360 plus or minus theta, on and on. Or from the y-axis, it's 90 plus or minus theta, 270 plus or minus. But this is nothing close to those ones. So it's a negative angle. And how do I address negative angle? Using method 1, just add 360, then you will address that problem. So this is cos negative theta minus 180 plus 360, something like that. So if I add 360, it means this is going to now adjust to negative theta plus 180, which is basically what? Cos 180 minus a theta, which is going to be cos 180 minus a theta. Now we've addressed the sign problem. I can say this is in the second quadrant. What is cos in the second quadrant? Cos in the second quadrant is a negative. But where is the function coming from? From the x-axis. So it remains negative cos theta. You've simplified that. Okay, I've simplified that expression. Okay, right. Now, in as much as we've simplified that, this can also come in terms of a square. Let's look at how you manage this if it was presented in terms of a square. Right. Now, look at this one. Let's look at this one. This is C. Right. On your C, you are given something like this. You are given something like this. Simplify. The following. Right. I'm simplifying something like cos squared 90 minus theta. Now, how do I simplify that? Go to this expression. There is a square. Open a square bracket. Remember, once there is a square, you start with a square bracket. That is 90 minus a theta. Close that, then you say squared. Look at that. Now from there, I'm going to simplify what is inside. This is 90 minus a theta. 90 minus it's a normal angle. I don't add 360. Take note, because it's a normal angle. 90 minus a theta, we can identify that this is in the first quadrant. In the first quadrant, what is this expression? In the first quadrant, I can say this is going to be what? What is cos in the first quadrant? It's a positive. But if it's a positive, where is the function coming from? This function is coming from the x-axis, from the y-axis. Sorry, 90 is from the y-axis. So since it's coming from the y-axis, I'm going to change to its complementary function, which is positive sine theta. Then I'll close that. All squared. If I square it, that will give me sine squared theta. There you go. So my take on that is, don't always add 360. Why are you adding 360? It's simply because it's a negative angle. If it's not a negative angle, then there's no point in you adding 360. Okay, so if you are given a square, something like this, you are given, say, sine squared, then this is theta minus 90, something like this. Okay, this is going to be what? Open a square bracket, sine theta minus 90, close that, all squared. This is going to be equal to, right? If it's sine theta minus that, I can say, there you go. Look at the angle. If you look at this angle, under normal circumstances, we're supposed to be 90 minus a theta. But this is now theta minus 90. Then it means it's a negative angle. I have to adjust it. How do I adjust that? I'm going to add a revolution. This is theta minus that plus 360. Close that. Then I'll close the square bracket. Look at that. Okay, right. Now simplify this this expression. I'm going to say this is now sine. There you go. If I add that, this is going to be theta. It's plus 270. Close that. Something like that. So this is now going to be, close that, sine 270 plus a theta. I'm now rearranging it. Simplify. What is sine 720 plus a theta? I'm simplifying. First things first, identify the quadrant. Where is this? This is actually the fourth quadrant. If you go back to your first classes, you realize that this is in the fourth quadrant. What is sine in the fourth quadrant? Obviously, it's a negative. But where is the function coming from? 270. Is it on the y-axis or in the x-axis? You go to your diagram, 0, 90, 180, 270. 270 is on the it's on the y-axis, and once it's on the y-axis, you change the trigonometric ratio to its complementary function. This becomes positive cos theta, all squared. Now square the answer. That will give us what? Negative cos squared theta, negative cos theta, all squared. That will give us cos squared theta. There you go. Right. That's how you simplify such an expression. Okay, right. I want us to look at numerical angles, but these numerical angles are negative angles. Okay, negative numerical angles. Okay, let's look at example number 2. How do I deal with negative angles when they are numerical? How do I adjust them? How do I simplify them? That's the question. How are you going to simplify numerical angles that are negative? Okay, right. Let's look at this. Let's look at this. Um, simplify the following numerical angles to their acute equivalence, or just write in short, we can just say write them in terms of theta only. Okay, right. Now I want us to simplify the following angles. I'm given something like this: sine negative 120, and the question is simplify this. Now, how do I simplify this? Very, very simple. How do I simplify these expressions? Okay, now I'm going to say this is a negative angle, and I said negative sine negative of an angle is going to be the same as negative sine theta. So I can take this as an identity, means that the left hand side is the same as the right hand side. So if I'm given any negative angle, which is sine like 120, it means this is the same as negative sine 120, just following that pattern. So it means if this is sine 120, it is the same as negative sine 120. If this was cos, if it was cos negative theta, that would be given as what? Cos theta. Why? Because this is in the fourth quadrant, according to what we deduced. And if it's in the fourth quadrant, cos is what? Positive. So it remains positive cos theta. This is in the fourth quadrant. Sine is negative in the fourth quadrant, so it's negative sine theta, something like that. The same goes for your tan. We developed this in my previous illustration there. This is tan negative theta, and we said it's the same as negative tan theta, simply because this is in the fourth quadrant. Is that okay? So once you come to sine 120 like that, sine negative 120, it simply means you can just come and say negative sine 120. Now I'll break down sine 120. It's going to be sine, open a bracket, 180 minus What am I supposed to subtract from 180 to come up with 120? It means I'm supposed to subtract what? 60 degrees. This is going to be negative. I'm reducing now. Sine 180 minus 60. It means it's going to be positive sine 60. And your answer is going to be what? My answer is going to be plus minus, which is now negative sine 60. We can leave it like that. Okay, so whenever you are given a negative angle, look at this. Look at B. I've got tan what? Negative tan negative 200, something like that. Tan negative 200. Check. First, this is a negative angle. From the identities, I know that tan negative of a theta is the same as negative tan theta. So I can say this is negative tan 200. Following this as an identity, I can write the same, this ratio in terms of the same pattern. This is going to be equal to negative tan, open a bracket. What is 120? 120 is an angle in the third quadrant. If I will locate that one, if it's in the third quadrant, I'm simply going to come and say, look at this. This is going to be 180 plus in the third quadrant. Remember, anything in the third quadrant, we say 180 plus a theta. In the second quadrant, it's 180 minus a theta. In the fourth quadrant, it's 360 minus a theta. So what should I add to 120 to get 200? Add 20. Then this is going to be minus the one which is outside. This is the third quadrant. What is tan in the third quadrant? Obviously, it's positive. So it becomes positive tan what? 20. And that is going to be negative tan 20. Simplified. Okay, that's managing your negative angles. Okay, any angle that you are given, let me give you the last one for your cos in the same example. This is cos what? I can still say cos squared negative, say cos squared negative 150, something like that. This is going to be equal to, I'm simplifying this. Look at that. I'm simplifying that. There's a square there, so I'm going to open a square bracket, which is going to be cos what? Negative 150. Close that. Then you say all squared, right? But this is a negative angle, so I'm going to say negative cos negative 180. From the identity, we know that cos of a negative theta is just cos theta, something like that. So if it's cos, if this is given by, if this is cos 150, it means it reduces to just cos 150 all squared. Okay, in that case, I'm now breaking down inside the bracket. I can say, take this to be open bracket, cos. Which quadrant is 150? Is the second quadrant. So I can safely come and say this is 180 minus. What am I supposed to subtract from 180 to get 150? Obviously, I'm supposed to take away 30. Close that, all squared. Right, now there you go. This will be simplified inside that bracket. It means this is negative cos 30 all squared. Why? Because angles in the second quadrant, what is cos 30? It's a negative. If you simplify that, it becomes negative cos 30. Square that, becomes cos squared 30. That's how you simplify such a negative angle. Very, very important. It's just a basic routine that you have to follow. It's not something that is out of this world. I'm sure if you keep wrapping it up, you will see that there's nothing much that we are doing. We are just twisting and turning on the same thing, right? What about if this was to be sine negative, say 480, something like, which is more than a revolution? There are two methods that you can use, right? The first method, someone can say, let me take it in this format. Method one, look at this. If I'm to simplify it, I can safely just say sine of a negative angle. This is basically going to be negative sine 480 because it's a negative angle from its identity. Then I'll break down. This is more than a revolution. So 480 is more than, I can just subtract a revolution. If I subtract a revolution, I'll get what? 480 minus 360. That will give you 120. Now simplify, this is a negative sine 180. Sine 180 minus, this is the second quadrant. It becomes 180 minus, what should I subtract to get 120? You subtract 60. This is going to be equal to what? Negative. What? Sine 180 minus 60 is in the second quadrant. So it means this simplifies to plus sine 60. And your answer is just negative sine 60, something like that. What about if I'm to take it with method 2? If I'm to take it with method 2, someone can say sine negative 480. Since it's a negative angle, I'm going to add a revolution to address that problem. So I'm going to say this is now sine what? Negative 480 minus plus 360. I'm adding a revolution. That will give me sine what? Negative 120. But sine negative 120, I can still say, let me apply the identity. That's a negative sine 120, something like that. Then sine 120, I can break that one down. It's a negative 180 minus a 60. That will be negative what? Plus sine 60. If you look at it, sine 180 plus a 6 is minus a 60. It's in the second quadrant. What is sine in the second quadrant? It's a positive. That's why I'm now saying plus sine 60. Plus minus, that would give you negative sine 60, which is basically the same as that. Okay, right. That's how one can simplify your negative angles. Okay, right. Hope you managed that. Thank you for your time. It was nice having you around. Let's look out for more videos that are coming on EduBlush. We are developing your trigonometry. This is work that you are supposed to cover in the second term of your grade 11. Keep following. We are supposed to go through each and every section, and I hope and pray that as we are developing, you are also following. If there is a challenge and you feel you need more on this, please, you can forward your request to us, and please keep following. I'm going to also give you an activity on these things so that you can keep also practicing, and perchance you meet a challenge, forward it to us, then we'll assist you in due course. Thank you.